Hello everybody, I'm here in my dorm, and I apologize for having not uploaded a video in a while, but I've been extremely busy, and I will be busy for quite a while, so unfortunately, there's only going to be this, or maybe some other very short stuff as well. But this video, I definitely have the time for because it's extremely quick. What you see here are these nice optical filters. They're from an old physics demo kit that was getting junked, and you can see they're labeled Didymium. Those of you who are familiar with this will know that glass blowers like to use it because it cuts out sodium emission lines, particularly the 589 ones, which are by far the most prevalent emission lines of the sodium atom. And for those of you who are unfamiliar with Didymium, it's got that interesting name because it consists of two rare earth elements that have ium in their name. So we got praseodymium, which probably butchered the pronunciation, and then we also have neodymium, which is also rare earth. I believe they're 2 or 3 elements away from each other. I'm not a chemist, but what's very interesting about this glass is in normal lighting it would look pretty much transparent. I'm not in normal lighting right now. You'll find that out soon. But if you were to hold this up to the sun or an incandescent light, everything would look pretty much the same. The only giveaway would be if you happen to take a diffraction grating and point this and look through a diffraction grating through this filter as well into a incandescent light, where you notice that along the perfectly smooth blackbody radiation spectrum that you'd expect from the lamp, you're also going to see a dark band right where the sodium line should be, about 589 nanometers. And it's pretty interesting. It's an extremely sharp, narrow band, but it's there. And today, now that I have these, we're going to go look at just how effective these filters actually are. The reason why glassblowers want these is because if you're working with glass, especially soda lime glass, there's a lot of sodium ions in that glass, and as you heat that glass up, what's going to happen is that those sodium ions are going to get excited and emit their characteristic yellow wavelength. The problem is that it's very bright. I mean, as you can see from low-pressure sodium lamps, it's a pretty effective wavelength for lighting things up. So what happens is, as you're working with the hot glass, the glass becomes kind of shielded by this bright yellow flare, and you can no longer really see the glass you're working with. It's straining your eyes. It's not very nice. So the answer is you use this stuff, and it will cut out only the yellow light from the sodium, and you can still see the color temperature of the glass, right? The blackbody radiation curve of it is pretty much unaffected, so if you're working with glass that's around 1,000 Kelvin, it's still going to look orange. Well, not 1,000 Kelvin, I guess it'd be like 2,000 Kelvin or so. But if you're working with hot glass, it's still going to retain its blackbody temperature, so you can blackbody emission. So you can still figure out what temperature glass you're working with. You can still see the surface really nice if you're doing surface work on the glass, but you do not have that annoying glare. Now, of course, when it comes to that annoying glare, that's all perspective. I mean, I personally kind of like it, but so that's where we get to the second part of this. Is if we pan out a little bit, I apologize for the mess. I really probably should have cleaned up. But so here we have my fine dorm room. We've got a high-pressure sodium lamp, and over here we've got 135-watt SOX lamp. Because your dorm needs this. You might not know it, but this is what you need. So we got this filter, right? And we clearly have a very bright sodium lamp, and we're going to put the filter in front of the lamp. And lo and behold, it's significantly more dim. In fact, if you look at it just with your bare eyes, the camera is not necessarily doing it justice. The lamp looks extremely dim. All the light in the room starts just coming from this fluorescent light. Now, what's really cool is I have 2 of these, right? This one's also labeled that. So we can stack them, and unfortunately you'll notice that this one is a little foggy. It's just a property of the surface. It's a manufacturing defect or something. But it still works just fine as a filter. So now we have 2 of them, and we can actually see now the buffer gas in this lamp. There's absolutely no yellow left. What we're seeing here is just pure neon and argon buffer gas that's used for heating up the sodium when you first turn on the lamp. And of course, we expect it to still be there. It makes sense. The lamp is still running, but now we can see it because it's no longer being masked out by these sodium lines, which are otherwise completely dominant on this lamp once it's heated up. So that's pretty cool. And if we go over here to the high-pressure sodium lamp, we can now see that it looks extremely reddish because we cut out all the yellow light, so what we're seeing now is the red peaks from various other impurities in there, along with also some of the black body radiation from the extremely hot ceramic capsule in there where the actual arc takes place. If we drop one of the filters, we can see now that it's still pretty cut down. I mean, it's definitely a lot brighter, but you'll notice that everything's a lot more clear. It's no longer a terrible glaring mess. You can see as I slide it, just how dramatic the difference is, right? Because this camera is doing its best to keep the aperture constant, but I can still thwart it by moving this filter. So anyway, that's this quick quote-unquote demo. I mean, I just found that really interesting. I expected a dramatic effect, but as I've mentioned, looking at this in person, it's very impressive, because this lamp right here is about 20,000 lumens, slightly over that. And the fact that we can just cut it out with a, albeit fairly thick slab of glass, is very impressive. So that's all for now. I'm not quite sure when the next video is coming, or what it will be about, but there'll be something. Maybe lighting related, I don't know. Some cool electronics projects possibly, but anyway, I'll see you in the next video.